Here we're asked to find the limit in 3 different situations, and each one of them will yield what's called an indeterminate form. If I was to substitute -1 in over here, I would get 2 times -1 squared minus 2, and in the denominator I would have -1 plus 1. Well, in doing this, I would have 0 in the denominator. The numerator, -1 squared is 1, then I would get 2 minus 2, and I would get 0. So this is an indeterminate form. Over here, if I was to do the substitution for infinity, what I would get is infinity minus 1, which is infinity. And in the bottom, I would have infinity plus 1, which was, again, infinity. And this is also an indeterminate form. And in this one over here, in the first term, if x approaches infinity, I would have infinity minus infinity. And that, again, is an indeterminate form. Before we use L'Hopital's rule, first we're going to look at all 3 to see if there's an algebraic manipulation we can do that would yield a limit answer. So in this first one, I can simplify this by factoring out first a 2 on the top, and then noticing, well, I'll write that I have x squared minus 2 here, x squared minus 1. But this is a difference of squares, so I'm going to change that to be x plus 1, x minus 1. And in the denominator, nothing changes, it's x plus 1. Now noticing I have x plus 1 in both the numerator and denominator, I can divide through and it'll be 1. So what's left on the top is to distribute 2 times x minus 1, which is 2x minus 2. So when I substitute in here, I'm going to have 2 times minus 1 minus 2. I'll do this first, so minus 2 minus 2. And it yields a final answer that my limit is a minus 4. I'll write that off to the side over here, just for reference for when we use L'Hopital's rule. On the second one, even if you're good at algebra, the manipulation's not obvious, but I need to change this numerator to get the x in a position where it's not going to affect what the limit is. So what I'm going to do is look at the 2 terms isolated. So I have 3x squared minus 1. And if I divide both terms by x squared, what I would get is 3 on its own, because this is both going to be 1 and 1. So I would get 3 on its own. And then the minus 1 over x squared, as x approaches infinity, this would go to 0 and would drop out. And in the denominator, I would do the same thing. I would have 2x squared plus 1. I want to divide both sides by x squared to get the 2 by itself. And what I would get is 2, this time plus 1 over x squared. So here, if I substitute in, as this goes up to infinity, this value of this fraction would go to 0 and would fall out. So algebraically, I can find that this limit as x approaches infinity is 3 over 2. So I'll write that over here too. I have 3 over 2. The third one is not something we're going to be able to do algebraically. If I was to factor out an x from both terms, I would still have x minus 1 inside. And if I substitute bigger and bigger numbers as x approaches infinity, this would be infinity times infinity minus 1, so there's no help there. So over here, I'm just going to put a question mark. So now we need a working definition of what L'Hopital's rule is, and basically it says that the limit of f of x over g of x is equal to the limit of f prime of x over g prime of x. Now this is not utilizing the product rule for derivatives. This is just simply taking the derivative of the top and the derivative of the bottom. Anyway, so if we have the limit as x approaches minus 1 And what I'm going to do now is do g prime of x. So the derivative of the numerator is going to be 4x. And then the derivative of the denominator is simply 1. What we get is 4 times minus 1 over 1, which is minus 4 over 1, or just 4, which is what we got before algebraically. Let's look at the next one. So this time, we're going to have limit as x approaches infinity. And we're going to take the derivative of the numerator, which is 6x, and the derivative of the denominator, which is 4x. We can divide through by the x's, and what we get is 6 over 4, which reduces to 3 over 2. And we see again, that worked. Now this one over here, the indeterminate form is infinity minus infinity. And the way that this would work is we would have the limit as x approaches infinity of, I'm going to take the derivative, so I get 2x minus 1. And if I was to now, as I approach infinity, this here would become infinitely big, and I would only be subtracting 1. So the answer for this one is infinity. We'll continue on with a few more examples just so that you don't have a false sense of security. So we have the limit as x approaches 2. And then I'm going to take the derivative of the top. So if I was to actually substitute this in, the 2, I would get 2 squared is 4. 4 minus 2 is 2, minus another 2 is 0. And then on the bottom, I would have 2 minus 2. So this is an indeterminate form of 0 over 0. So I'm going to take the derivative of the top. So this is going to become 2x minus 1, first derivative. And then this over here would just simply be 1, and the minus 2 would fall out. Now when I substitute in the 2, what I would get is 2 times 2 is 4, minus 1 is 3. So this limit equals 3. So in this practice problem, when we have x approaches 0, this here is going to approach 0. So I'd have the square root of 4, which is 2, and 2 minus 2 would give me a 0 in the top. And then as x approaches 0, the denominator would also become a 0. So I have the indeterminate form of 0 over 0. So applying L'Hopital's rule, what we're going to do now is to take the derivative of the top. Well, this here is 4 minus x squared to the 1/2 power. So I'm going to have to apply the chain rule to do the derivative of this. So I have 1/2 times 4 minus x squared. I reduce the power by 1 since it was 1/2. Now it's minus 1/2. And then I take the derivative of the inside function, which is minus 2x. And the derivative of the bottom is just 1. Now I have to rewrite this because this being to the minus 1/2 power moves to the bottom. Correct form would be to make the 1/2, put the 1 here and the 2 down here, and then divide, but I'm just going to take half of minus 2x here. And then in the denominator, I have the square root of 4 minus x squared. Further simplification. This would be minus 1. And then in the denominator, as x approaches 0, this term falls out, so we just have the square root of 4, which would be 2. And at 0, this numerator would then be minus 1 times 0 over 2. And a fraction is negative, fraction's negative when the numerator is negative, and a fraction is 0 when the numerator is 0. So my final answer, as for the limit, is simply 0.